Okay, so here is 1.5 extra practice problems, and these are the detailed answers. So I will go and explain. We notice in this problem it says solve the equation, so we're going to isolate the variable. The first thing we should notice are that we have variables on both sides. Which one are we going to get rid of? Well, we've already got our constants consolidated on the left side, so we're going to take this variable and we're going to move it to the other side. So we just don't move it. We want to get rid of it on the left side. So we want to get rid of a negative 3x. So we're going to add 3x. These would cancel. You're left with 12 equals negative 3x. And now we want to isolate the variable. So negative 3 is multiplying. The inverse operation to multiplication is division. So we divide by negative 3. And it gives us negative 4 equals x. Problem number 2, this time, we have variables and constants on both sides. And we're always going to move the variables first. Move the variables first. So it doesn't matter if we move 6a over or 3a to the other side. I'm going to move this manner. That will cancel and I'll be left with a positive variable. Just makes it easier, less negatives, less places to make mistake. So if my variable's on the left side, I'm going to get rid of that constant. What gets rid of a negative 4 is a positive 4, and we're left with 3a equals 9. Divide by 3, divide by 3, a equals 3. Again, we have variables and constants on both sides. I'm going to move the variable over to the right. What gets rid of a negative 5z is a positive 5z. That leaves me with 7 equals 17 plus 10z. I'm going to subtract 17. That gets rid of the positive 17 on the right. Leaves me with negative 10 equals 10z. Divide by 10 gives me negative 1 equals z. We can always go and plug that value back in if we want to ensure that our solution is correct. I'm going to move my variables to the right side. We're left with 45 equals 5k plus 25. We'll subtract 25. That leaves us with 20 equals 5k. Divide by 5. 4 equals k. And we should be able to do these problems this fast and quickly. We should not be overwhelmed with two-step equations once we move that variable over. And what we are becoming proficient at right now is how to tackle equations with variables on both sides. We need to remember that when we have two variables on the same side, opposed to this, which are variables on opposite sides, but when we have them on the same side, like this right side, we need to combine like terms. So we're going to simplify if necessary. So if we can simplify a side, we must do that first before we start moving things around. Left side simplified, right side simplified. Let's get rid of the variables, or let's move the variables to one side. We get 2q plus 6 equals negative 2. We're going to subtract 6. 2q equals negative 8. Divide by 2, divide by 2. Q equals negative 4. Again, we can combine like terms. We have like terms on the same side of the equal sign. We can only combine the ones on the side. We cannot combine those two because it is on opposite side of the equal sign. So that is my demarcation. So now I don't want yellow. So I have 8, 6x minus 10x is negative 4x equals 16 minus 8x. I'm going to move the 8x over to here, so I end up with a positive variable. 4x equals 16. I'm going to subtract the 8. 4x equals 8. I'm going to divide by 4, x equals 2. This time, there's a number of ways to go about doing this. I'll do the most, probably the most 8th grader-ish, is by distributing. Distributing those terms, you get 2 times 4b, which is 8b, and 2 times negative 6, which is negative 12. And then we have 4 times 3b, which is 12b, and 4 times negative 7 is negative 28. And now I'm going to subtract 8b, move the variables first. Don't forget that negative with the 12 equals 4b minus 28. Add 28. That's 28 and 12. The signs are different. So we're going to get positive 16 equals 4b. I had more positives than negatives. I have 28 positives, 12 negatives. We're going to divide by 4, and we get 4 equals b. Now, the other way we could have done this problem, not necessarily always the most efficient, but we can do it. Let's show. I'm going to get rid of, I'm going to divide both sides by 2. That cancels these two. You're left with 4b minus 6 equals, these cancel, and I get 2 times the quantity 3b minus 7. 4b minus 6 equals 6b minus 14. Subtract the 4b. Negative 6 equals 2b minus 14. Add 14. Add 14. We get 8 equals 2b. Divide by 2. And we still get 4 equals b. Same answer, just a little different. And I chose 2. I wouldn't choose 4 because if I multiplied this by, if I divided that by 4, I'd end up with 1/2, and that's definitely not going to be easier. But we could have, you could have, because then you distribute the 1/2 into the 4b and the negative 6, and you get 2b minus 3, but equals 3b minus 7, but we're getting way too crazy. All right, so do I get rid of the denominator? I don't in this case because 48 and 16, the coefficients, are multiples of my denominator. So I know going forward that that's going to cancel. When I multiply 3/4 times 48, 4 goes into 48, 12 times 3 is 36. And then I distribute the 3/4 to the negative 16. The 4 and the negative 16 cancel to make negative 4 times 3 is negative 12x. And these are all mental math, no calculators, no decimals, no nothing. And now I'm going to distribute this, and we get 16 plus 8x. I'm going to move my 12x over, and that is going to leave me with, sorry, just 1 second. I am moving along with my work. That gives me 36 equals 16 plus 20x. Subtract 16. Gives me 20 equals 20x. I'm going to divide both sides by 20. 1 equals x. Perfect. Awesome. All right. Now, again, I don't need a calculator. I can think about this quite naturally, but we would be distributing 0.6 times 5r. Well, 6 times 5 is 30, plus the 1 decimal point is 3. 6 times negative 4 is negative 24, plus the decimal point is negative 2.4. Plus the r, which is not affected by the distribution. That's not in the parentheses, Chewbacca. It's outside of Chewbacca. and then we get 21 minus 9r. Let's simplify. We have like terms on the same side, so we're going to combine those before we move things, before we start dealing with our decimals and our variables, our decimals, our constants and our variables. I'm going to move the 9r over, and I'm going to get, what's that, 13r minus 2.4 equals 21. I'm going to add 2.4. I get 13r equals 23.4. I'm going to divide by 13, and that to me is not a logical answer. I don't see that 234 is a multiple of 13. It might be, but I'm going to pull out the calculator here for accuracy purposes. Divided by 13 leaves me with 1.8. 1.8. So 13 goes into 234 18 times if you want it. But that answer is acceptable. I'd also include 1 5/6. 5/6, excuse me. 1 4/5. See, this is the problem. I would have made a mistake. There's no need to convert it. We can leave it just like this, or 9/5. Just leave this. This is acceptable. This is overextending. It's overdoing. We don't need that. But if you gave it, that would be acceptable. Here, what are we distributing? A lot of students would distribute the 8, but you need to understand that that is a negative 8. How do we know it's negative? Because we look to the left to see if a number is positive or negative. But we're going to distribute a negative 8 and a negative 6. So 3x, negative 8 times 2x is negative 16x. Negative 8 times 3 is negative 24. Negative 6 times 2x is negative 12x. Negative 6 times 5 is negative 30. Let's combine like terms. That gives me negative 13x minus 24 equals negative 12x minus 30. And, sorry. And we're going to move the variables. I'm going to move 13x over, negative 13x over. These cancel. Negative 24 equals x minus 30. Add 30. Add 30. More positives than negatives. So my answer is going to be positive 6 equals x. And we are good to go. Next problem. Solve the equation. So we are going to distribute. We get 16f plus 24 equals 16f plus 24. Move the variables first. We move these variables and we notice something unique happen. They cancel. You're left with no variables. And it leaves you with a number statement. And now we look at that number statement. We see that it's a true statement. And when the variables cancel and they produce a true number statement, my solution is all real numbers. It is an identity problem where it produces a true statement and there are an infinite number of solutions, but I want to know what specifically. When you say infinite number of solutions, you're not being specific about what they are. All real numbers is a set of numbers, and it includes every single number because every single number is a solution to this original equation. So the only thing that I'm going to accept is all real numbers, not all real solutions, not real number solutions, not an infinite number of real solutions. The only solution is all real numbers. We again are going to simplify this problem first by distributing. We distribute because those are unlike terms and we can't combine 4s and 12. So the only way we can simplify this left side of the equation is through the distributive property. We get 24s plus 72 equals 24s minus 30. What do we get? That's going to be 112 minus 112. 8 times 4 is 32, so there's the 2. You carry the 3. 8 times 1 is 8, plus 3 is 11. So yeah, we're gonna get rid of the variables. They cancel. You're left with 72 equals negative 112. That is a false statement. And so that answer is no solution, meaning no number can go into this variable, these variables, to make the left side equal to the right side. There is no solution to that problem. That's a good one. Number 13, I'm going to distribute because notice the coefficients, the numbers in the numerators are multiple of the denominators. So I know I'm going to get good numbers. 3 goes into 6 2 times the numerator 2 here gives me 4j. 3 goes into 9 3 times the 2 is 6. So when I multiply those two, I'm going to get those solutions. And we're going to move the variable, minus 3j gives me j plus 6 equals 7, minus 6, j equals 1. So I got a solution. When my variables don't cancel out, I know that I'm going to get a single solution. So here's a great one. Here's a fun one where you want to see, hey, I've got denominators. I got fractions. I can work with those, but it's going to be far easier to look at the denominators and find the least common multiples. Multiples of 5 are 5, 10, 15, 20, 25. Multiples of 2 are 2, 4, 6, 8, 10, 12, la la la. 10 is 10, 20, 30. So we're looking for common numbers. Well, the first one, and the only one on this page, are 10. If we kept going in 2, we'd end up with 20. And then that would be the next common multiple. But this is the LCM. LCM would be 10. That's your least common multiple. So our LCM is 10. So if we multiply everything by the common multiple, we will get rid of those denominators. 10 times c over 5, the 5 and the 10. 5 in the denominator cancels with 10, and we get 2c. That was not a good c. Then we multiply c over 2 times 10. 2 in the denominator cancels with the 10 in the numerator to get 5c. And then the 10 and 10 equals 7c. This is a good problem. So we shouldn't move things. Let's simplify because we have like terms on the same side of the equal sign. So we get 7c equals 7c. Now we want to move the variables, not divide. If we divide, that doesn't get rid of the variables. We're going to move this variable, so I'm going to subtract 7c, and we get 0 equals 0. My variables cancel. I'm left with a number statement, 0 equals 0, and we look and we see that that is a true statement. So my answer is all real numbers. That's my solution. All real numbers are the solutions. I can't write every single number because we'd be going all day. So we write that in order to signify every number possible. Let's distribute by simplifying. 2.5 times 8. 8 and 8 is 16, plus half of 8, which is 4, which makes 20x. 2.5 times 2 is 5. Again, not needing a calculator. I'm going to get rid of the variables. We're left with 5 equals -4. 5 does not equal 4, -4, nor 4. So that's false. So my answer is no solution. I must write no solution. I cannot just write false. False doesn't mean anything. It's just speaking specifically to that number statement. I need a solution. And my solution is there is no solution. So 1/2 times 10 is 5. 1/2 times 12n is 6n. 1/3 of 15n is 5n. 1/3 of 15 is 5. We're going to move the variables over. We get 5 plus n equals 5 minus 5. We get n equals 0. That is a solution. 0 can be an answer. 0 is the only number. Since the variables didn't cancel out, we were left with n. We were given one solution. That solution in this example is 0. All right, number 17. You walked for 2 hours to reach a pier. You walk 1.5 miles per hour faster on the trip home. The trip back takes you 1 hour. How fast did you walk on the trip to the pier? So we're going to use the formula distance equals rate times time. So when I walk to the pier, I'm walking for 2 hours and I'm not given my rate. So my rate is r. I'm going to give the variable r and my time is 2 hours. That's okay. And then coming home, I walk 1.5 miles per hour faster on the trip. So I'm going to add 1.5 to my rate of speed. And on the trip back, it only takes me 1 hour. And that makes sense because if I'm walking faster, it's going to take less time. So when we see this equation, we know the distances are going to be the same. Distance 2 is going to equal distance back. We say distance sub t should equal d sub b. Subscript is below the variable. So what is my rate of speed going to? That was r. And how much was my time? 2 hours. And coming back, my rate of speed was r plus 1.5. And my time was going to be 1 hour. So I have 2r equals, we're going to distribute that, and we get r plus 1.5. Let's move the variables, and that leaves me with r equals 1.5. That's my rate of speed, miles per hour. Does that answer the question? Let's see what the question is. How fast did you walk on the trip to the pier? So this is the 2. This one's the 2 to pier. My rate of speed is r. I solve for r, and r is 1.5 miles per hour. So I walked 1.5 miles per hour there. How fast did I walk back? 3. Very good. 1.5 plus 1.5. This is my rate of speed on the way home. If I walked r is 1.5, I'm going to add it to 1.5 and get 3 miles per hour on the way home. Okay, so 1 serving of oatmeal provides 16% of the dietary fiber you need daily. You must get the remaining 21 grams of dietary fiber for the other sources. So 16% equals the oatmeal. So the remainder, well, what value, 16% plus what gives me 100? Well, that would be 84%. 84 plus 16 makes 100, so this is the remainder. So 84% is the remainder, and it says, I don't know how much the oatmeal is, but it says you must get the remaining 21 grams. So 84% is 21 grams from the other source. So I know this piece of information now. I know that 84% is 21 grams. So I can write 84 over 21. This is the percent. This is the grams of protein. And I want to know how much do you need total, I think it says. How many grams of dietary do you need daily? That's total. So I can use that proportion for 100%. And how many grams does that equate to? So we're going to do 84 times x equals 21 times 100. 84x equals 2100. Divide by 84, divide by 84. That's not a number that I would know off the top of my head, so I'm going to use my calculator. There are some problems that you're just not going to know. 25. So I would need 25 grams total daily of fiber. So that's the total. 16 would be from oatmeal and 25 would be total. So that remaining would be 25 minus 16, or 19, I think. 19? Nope, not 19. 9? 9? No. What is it? Oh, that's 16%. Sorry. Sorry. 21 grams minus 25 would be 4. So 16% is 4 grams. Would be, the oatmeal would provide 4 grams of fiber, plus the 21 equals the 25 total grams. Those are extra credit problems, or maybe the next one. Okay, nope. So 50% of the dietary fiber in one serving of oatmeal is soluble fiber. So 50% of the dietary fiber in one serving of oatmeal. Oh, so all right, we did. So we know that there's 4 grams of fiber, total fiber, in one serving of oatmeal. So, and 50% of that is soluble fiber. So 50%, 0.5 times 4 grams would give us 2 grams of soluble fiber. How funny is that? So, I don't know if you saw how I got that 4 grams, but we know that 21 grams represents the remaining, the 84%, and we know this is the total. So I subtracted to get the 4 grams, which was in the oatmeal. I love it when we can figure that out. Good. Okay. That's not a bad way of finding out that solution. Find the values of a and b for which 2 blah 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 equals blah 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 blah. Okay, so let's simplify it. We know if it's identity that the left side needs to equal the right side. They need to be identical. So I have no idea what the right side is, so I'm going to have to simplify this. Notice what I distributed. 2 into that parentheses, and that's a -1. That needs to get distributed in there. A lot of students don't distribute that negative, and that gives me 10x minus 6 minus x minus 4. We're going to combine like terms. 10x and negative x gives me 9x. Negative 6 and negative 4 is negative 10 equals ax plus b. So a is the coefficient of x. So what's my coefficient of x? 9, so a equals 9, and b is whatever is added to that variable x, so b is going to be -10. Those are the two values for a and b. In order for it to be an identity, we know identity, the left side must equal the right side, so they can cancel, so the variables can cancel and create a true number statement. All right, number 20. So the value of the surface area of a rectangular prism is equal to the value of the volume of the rectangular prism. So surface area is going to be the external part. It's going to be the outer skin, and volume is going to be the inside, all the guts. Ooh. So the formula for surface area of a prism, we don't know if it's a cube because we don't know what that value is. So it kind of looks it, but we can't make that assumption with the given information. So we're going to do the lateral area. That's sort of like the waist. It's the area around. So if we did this, you would get a rectangle. And that rectangle, if we unfolded this, you'd have x units, 6 units, x units, 6 units. And we know that a rectangle, the area of a rectangle is going to be length times width. Now we know that is 6 units. We know the height of that is going to be 6 units. So how do we add those up? You have x plus 6 plus x plus 6, which is 2x plus 12. So we have 2x plus 12. That's the length times the width, which is 6, plus 2 base areas. So these are the base, that's the base. And we know that that is x by 6. So we have 2, and x by 6 is 6x. And that would be the 2 base area. So if we distributed that, that's 12x plus 72 plus 12x. That's just for the lateral area. Let's move this. Oh, this is going to be tight for time. Oh, look at that little answer down there. I meant to. Good. Let's move that back up there. So that's that. This left side is my surface. Is my surface area. So this gives me 24x plus 72. And now we want the volume, which is your base area. The base shape is a rectangle. So we would find the base times the height of the object. And the base is x times the height is 6 times the height of the object is 6. X times 6 is 6x times 6 is 36x equals 24x plus 72. Now we can solve it. We're going to subtract the 24x. We get 72 equals 12x, divide by 12, divide by 12, and that equals 6 equals x. So yes, that was a cube. It's going to be 6 units. We solved for x, and that's a pretty cool problem. Last one. Here we go. I got 4 minutes before that bell rings. All right. 31 less than 5 times the lesser integer of 2 consecutive integers. It's 3 times the greater integer. What are the integers? So first thing we need to understand and point out is 2 consecutive integers. So the first number is x. The second number is x plus 1. That's how we do consecutive integers. So 31 less than 5 times the lesser integer. This is the lesser. So 31 less than, that comes after. 31 less than 5 times the lesser integer. 5 times x, that's the lesser, is equals 3 times the greater integer. 3 times x plus 1. We need to put parentheses in there because we need to do 3 times that number. If we just had 3x plus 1, that would be 3 times the lesser plus 1. We don't want that. We want 3 times the greater value. So 5x minus 31 equals 3x plus 3. Move the variables first. 2x minus 31 equals 3. Add 31. 2x equals 34. Divide by 2. X equals 17. That's my smaller consecutive number. X equals 17. So x plus 1 would be 18. The 2 integers are 17 and 18. Boom, baby. All right. Good luck. Hope you took time to do the extra practice from section 1.5. Good luck.